Alrighty, guys. So today we're going to be talking about black hole food. Basically, there is a star that potentially could be, like I said, food for a black hole, maybe sometime over this year. But it's not the first time that this black hole has gone on a eating rampage. For the Sky Report today, we're going to be talking a lot about the moon, especially with the Hunter's Moon this October. That's going to be a very big event that's happening this week, so we'll have a lot of coverage on that. And finally, we're going to talk more about black holes. Continuing on, I guess this episode is really all about black holes, very black hole centric. But basically, we're just going to be talking about the first video of a black hole. So, how a group of scientists are trying to record in live time a black hole. Anyways, all that and more will be covered. This is Interstellar Insights. Alrighty, guys. So before I really start off this episode, for those that didn't listen, last week's episode I talked about aurora that was going to happen during that weekend-ish between last week's episode and this week's episode. And from where I live here in Maryland, this is some pretty cool stuff. Stuff that's worth going outside and taking a gander at. I will say that was pretty cool. I was actually in a marching band rehearsal outside when our band director noticed that there was aurora, and we took a moment, got some pictures. You couldn't really tell. The sky was just kind of like it was tinted red, like barely. I mean, there's some parts where you could clearly tell that was tinted red, but if you really want to see in detail, you had to take a picture. And I got some pretty good on-the-spot images of aurora that night. So, hopefully, maybe along with the poll, I'll just post those images out to kind of complement this episode. So, yeah, that's just something interesting I think is noteworthy that should be brought up, especially for what's happened this weekend. But anyways, without further ado, we're talking about black holes eating things. Excuse me. So, there's a discovery that's been made with Chandra and Hubble as they observe the night sky, and it's really regarding about a black hole potentially going up to the star and eating it. And the craziest thing is that this isn't the first time that this particular black hole was, or this isn't the first time the black hole has consumed something. That's how I should better phrase it. This actually happened in 2019 where a black hole, I believe, hit a star and it caused a tidal disruption event. That event was called, and once again, this is very poorly named, AT 2019 QIZ. Once again, very poorly named. I don't know why they name it like this. It's very hard to comprehend. I don't even know what the letters mean. The only logical thing is the fact they use 2019 because that's obviously the year that this event was recorded. But anyways, I'm losing track. I digress. But basically, from that incident, there was a disc that kind of formed. I wouldn't say, it's very similar to an accretion disk, but I don't believe that the proper terminology would be to call that an accretion disk, because it was just a disk around the black hole that formed as a result of the black hole consuming the star. But that's what happened, and then this disk kind of stayed in place for a little while with the star until eventually the star, or not the star, the black hole and the disk started moving towards another star, which is what we are observing right now, thanks to Chandra and Hubble in the night sky. So, and then part of recording this data from this tidal disruption event is that there's been it erupted a lot of X-rays that Chandra was able to pick up. Because obviously it's like Chandra X-rays, which where you expect Chandra to do all this stuff regarding picking up X-rays from other stars. But anyways, I'm getting digressed there. But basically every 48 hours, that particular area, that black hole, that star would just erupt X-rays. So really, once that black hole and even the star starts, releasing X-rays into the cosmos, and we pick it up here via Chandra, that means that this star has been food, and it has been consumed by this black hole. And yeah, and then obviously understanding all this very important for understanding black holes, especially with I forgot what it's called, like gravitational waves or something like that, and how that can impact the fabric of space and time, especially with the tidal disruption events and the characteristics of that. That's obviously very important, and I will say though, I think it could be pretty cool if this black hole manages to consume this star, and not too far from now. I do think that would be something pretty cool. That'd be a really cool story to cover, actually, because I don't think we've really dealt with. I mean, we haven't really dealt with anything like that on that level yet. But like I said, excuse me, I was yawning. Be a very cool topic to cover. If like I said, something like this does pop up where the black hole has gone on its second food rage, and of course I will cover it on this podcast. But anyways, enough of me yapping about black hole food. Let's go talk to this. Let's not talk to. Let's go talk about the Sky Report. Alrighty, guys, let's get into this week's Sky Report. Like I said, this week, Hunter's Moon's happening. I believe that's a supermoon. I don't know, but we'll get into some of that terminology later. But anyways, let's start off with, and before I forget, which I always do, all times are on Eastern Daylight time. So if you don't live on the East Coast, let's say you live out in Chicago, just figure it out. I don't care. I don't care about your problems. Just, if you lucked out if you live on the East Coast. So, cool. But anyways, tonight, I forgot to say the date. Today, Wednesday, October 16th. Tonight, the moon will reach perigee at 8:51 p.m., which puts the moon about 221,931 miles away from us, or 557, 163 kilometers if you're not American or you're some nerdy scientist like me. And then this also concurs with the full moon, almost perigee, if not at perigee, and that'll form a supermoon. But we'll talk about that later. But the other thing that really that's really happening today actually happened this morning regarding star cluster M44, which is also known as the Beehive star cluster, and that was out earlier in the day, kind of in the morning. So yeah, nothing really happened Wednesday, but Thursday, full moon is going to occur at 7:26 a.m. So that's going to be this morning, and it's going to lead to the October full moon, otherwise known as the Hunter's Moon, and then going back to what I was talking about with the perigee. Also, I should probably define this, but perigee and apogee are kind of the two two very important points of orbit for an object such as our moon, where perigee is when the moon is at its furthest, and apogee is when the moon is at its nearest to Earth, basically. So, yeah. And then since the full moon is happening near perigee, if not at perigee, this full moon is considered a supermoon, which is the only classification. Basically, a supermoon is when full moon occurs at perigee. I don't know if it maybe for apogee, but I don't know. But anyways, there's like four projected supermoons. Of course, we went through three. This supermoon, the Hunter's Moon, this October was the third supermoon. There's one more to go around the end of November, I would say, like November, mid-November, somewhere. Excuse me, somewhere of the month of November. I just yawned really, but yeah, somewhere in November, middle endish, another supermoon. But anyways, besides full moon, talking a lot about moons because Titan's going to be out. Titan is going to be shining at 8th magnitude in the evening with Saturn, which is going to be shining at 0.7 magnitude. So that'll be shining towards like the eastish area, I believe. Kind of pops out behind Saturn. But yeah, that is Thursday. Anyways, October 18th, aka Friday. The moon will be 50 degrees high in the eastern sky around 4 in the morning. And it's going to be shining at a magnitude of 0.2. It's going to be located in Gemini twins, like Gemini the twins or something like that. It's going to be next to star Pollux, but Pollux is actually going to be shining, I believe, 1 point higher, so it'll be shining at a magnitude of 1.2 in Gemini the Twins. And then another star that can be found is going to be Castor, and Castor is going to be kind of in the head of the two twins, and basically it'll stand there. It'll be in the taller one. It'll be there. It'll be very bright, and yeah, it'll be up there, very tall. So, anyways, yeah, that is basically everything that's going to happen in the night sky this week. All the big important stuff, if you know what I mean. But anyways, some times to give you tonight, the 16th. Sunset's going to occur at 6:18 p.m. Moonrise is going to yawns. Moonrise is going to occur at 5:52 p.m. and moonset's going to occur at 6:03 a.m. On the 17th, also tomorrow, Thursday, sunrise is going to occur at 7:13 a.m. Sunsets are going to occur at 6:16 p.m. Moonrise is going to occur at 6:20 p.m. and moonset's going to occur at 7:23 a.m. Now for Friday, the 18th, sunrise is going to occur at 7:14 a.m. Sunset is going to occur at 6:15 p.m. Moonrise is going to occur at 6:52 p.m. and moonset's going to occur at 8:43 a.m. And then, just to give you your moon phases, Thursday, or not Thursday, I'll say it later just so I don't say them out of order. Wednesday, we're going to be at a waxing gibbous, almost full moon. Thursday, like I said, excuse me. Yeah, I have been yawning all day. It's really bad. But Thursday, like I said earlier, moon's going to be full. That's the hunter's moon, and that's also going to be supermoon, judging by where the moon is in its orbit in relation to Earth, which in this case is perigee. So, supermoon. Anyways, Friday is going to be at a waning gibbous, turning away from the full moon. So yeah, that is this week's Sky Report. Let's go move on to our second big section of this show. Alrighty, guys. So moving into our second major section of this week's episode of Interstellar Insights, we're going to be talking about the idea of making a movie on an actual black hole. None of that animation stuff, none of the artist rendition, but like actually capturing a black hole in the night sky, being a black hole, basically. So, to kind of start off where this, this idea originated. It's basically, I think, in the Netherlands, in the EU. It's a bunch of scientists in the EU, but it's based out in the Netherlands. They're led by a Dutch professor named Heino Falke, and they're trying to make the first movie of an actual black hole. And so part of that is a big chunk. That weird noise was my chair hitting. But a big part of this is, finding the right telescope. So Falke has decided to use the Event Horizon telescope, which for those of you that don't know, it's basically just a global network of telescopes, like I said, basically with the main focus of capturing the event horizon of a black hole, because that's what we like doing and what we find interesting. So yeah, and then also this is excuse me, this is also just abbreviated to EHT. So really, I guess we have to do a little bit of history, but back in 2019, Falke had previously used EHT to record an image of a black hole located at the center of M87, the galaxy, which is located about 54 million light years away from Earth. I don't know why I paused so long on that, but yeah. Yeah, so and then Falke, I believe he got an award for that work. I believe I forgot from who, but he got recognized and he earned an award for his work regarding black holes. And then EHT was used later to capture Sagittarius A, which is the supermassive black hole which is in the center of the Milky Way. So yeah, so EHT has been used for black holes in the past. Wouldn't make sense that we use this technology to record black holes now, especially as we record them. But anyways, within this system of telescopes, the actual main telescope that is being used to record the black hole is going to be the Africa millimeter telescope, otherwise known as AMT for short. And it's basically this 15-meter wide telescope located in Africa, obviously. No, more specifically located in Namibia, in like South Africa. It literally borders South Africa if you look at a map. But I know there's a bunch of geographically illiterate people who don't know where countries are, because this should be common knowledge, but people do not know where their countries are and their continents and oceans, which is very sad. But I'm getting off topic. That is the inner geography kid in me, if you know what I mean. But anyways, that is the kind of main mode of recording this big old black hole in the night sky. Yeah, I don't know which black hole. I'm assuming it's going to be either M87 or Sagittarius A, since they've already got data on that. It would make I don't know exactly, but it would make logical sense to record one of those black holes. But anyways, so we got all of this, Falcon and his team has got all this gear. They know what telescope they're using. They know kind of what black holes to look for. And since, like I said, EHT is a big system across the globe, they're always able to constantly monitor the black hole. If, let's say, the AMT is not facing the black hole, then another telescope will be able to kind of snag it up on video recording. Well, not video recording. It's not like they're really recording. It's more like the with the EM waves and kind of spectrum. I don't know the best way to describe it, but it's not like the traditional. It's the more scientific version, if you see other videos. But yeah, like I said, they've kind of got it all sorted out. But the only main issue is the amount of digital storage. Like this project. Excuse me. Yeah, it's been a long day for me. But this project is expected, in terms of storage, to be 5 petabytes, which is roughly 5 billion gigabytes of storage, which is a whole lot. If I try to upload that on my computer, this computer is crashing, and I'll never be able to record another episode of Interstellar Insights. That's just how big it is. And it's so big that it cannot be transferred over the internet. So what they'll actually have to do is they'll have to basically be like a very big, external drive for your computer, just much bigger, very big, lots of storage. And they'll have to physically transport all this data regarding the black hole movie. And then I think once it's done, it should be released to the public. And then, of course, at that point, they'll do all the compressions and stuff to reduce storage. Because I don't think they really need that much storage. It's just being able to capture so many different waves and things like that they really want on camera. And then, they can compress it and, get all the visual stuff and get our first movie of a black hole. First ever. There's this. I probably should have emphasized how important this is at the beginning, but this is very important since this is the first time we'll be able to see a recording of a black hole. Like I said, besides artist renditions and just CGI animation and all that fancy stuff. Yeah. So this is big. Once we get all this data from observations from EHT and AMT, hopefully, sometime not too far in the future, we can see this video and, maybe we'll follow up on this topic. But anyways, that's all I've got, today. 2 topics on black holes, 2 very different topics on black holes. But we've done that. And then, of course, we've done our stuff with the Hunter's Moon. So with that being said, let's go do some astronomy trivia. Alrighty, guys. So welcome to this week's edition of Astronomy Trivia. And so before we get into last week's question, let's go and talk about, I said it wrong. Before we get into this week's question, let's talk about last week's question. So last week, I believe I asked which ancient astronomer had a geocentric model of the solar system. And since that is kind of a big word, geocentric just basically means basically around the Earth. So basically, had a weird burp yawn. Which ancient astronomer had an idea that the Earth was at the center of the universe? And that astronomer, I believe, it's like, mm, I forgot exactly who, but I don't think many people answered it right. But basically, the answer is Ptolemy. And I don't know, there's a bunch of people, there's ironically a bunch of people named Ptolemy in history, like the Ptolemaic dynasty after the end of the Macedonian Empire under Alexander the Great in Italy, but that's completely different. They're not related. But basically, Ptolemy was a Greek astronomer, basically lived from 100, he was roughly circa 100 to 170 AD. And basically, the work that he did, that he mainly published this idea in, was in Mathematica Syntaxis, which is like Greek, I believe. And basically, in that work of his, he basically outlines how the universe is geocentric and Earth is at the center of the universe. But of course, they were disproven by Copernicus in the 1500s, and of course, no one believed him because of the church. So really, it wasn't until Galileo and even probably by Newton's time did they really prove that Earth is in the center of the universe. But there's not really a center of the universe because the universe is always expanding. Basic quantum physics, which would not be learned till Hubble. But anyways, I digress there. The question to this week's edition of Astronomy Trivia, the question is, what was NASA's spacecraft that was sent to Venus in 1989? I'm going to read it again. What was NASA's spacecraft sent to Venus in 1989? All right, I'll put a poll out on YouTube and Spotify for the respective listeners of those platforms so you guys can have a crack at this question. In the meantime, that is all I have got for this section of this episode, so let's go wrap it up. Alrighty, guys, so that is about it for this week's episode of Interstellar Insights. Next week, regular song and dance, regular episode unless I make some post. And I'm also actually going to be posting some pictures of Aurora Borealis at the time of this episode's release, so go check that out on YouTube. Regular song and dance. There is a bonus episode coming out this Friday where I interview my good friend Matthew Spears and Spears, not Spheres. It's not like his head is, it's not like built as spheres, like something out of, I don't know, Roblox or something like that. But I interview him. We talk about some off-topic stuff. The bonus show is really made for off-topic discussions and stuff. So, we'll talk less about astronomy, more about random stuff. Like, I remember the first episode we did, Jeremiah, we talked about VR games and being a ginger, because that was, I don't know, hilarious because it's Jeremiah. But yeah, we just talk about some fun stuff. It's not as scripted as this. It's more casual. Just talk about random stuff. Much longer episodes, but yeah. I'm going to try to keep a consistent schedule for the bonus show. Try and integrate it, so we might do the regular show Wednesday and then the bonus show Friday. I think that's the arrangement I would like. I think it'd be very good. So yeah, anyways, if you really enjoyed this episode, really appreciate it if you could give me a like and subscribe. Of course, that means a lot to me, but it also supports the show. We can improve the quality. Who knows, maybe we'll grow big enough that, some people in the field of astronomy or astrophysics will want to come on and interview us. But anyways, that is all I've got. This is Michael signing off.